Hey TypeScript fans, today we'll look at the X-Men and we will learn what the X-Men have to do with TypeScript and with testing. And I also want to introduce you to William Stryker, who is actually an opponent of the X-Men because he doesn't like mutants. And that's why a testing framework was named after him. We don't want that our code can mutate without our tests finding out about these mutations. That's why I will look with you today at the Stryker Mutator testing framework. And it's available for Scala, for C#, and for JavaScript, TypeScript. We'll set it up for TypeScript, and then we will learn what is mutation testing and why you should employ it also in your projects. It's quite easy. So I just have one more slide. And it tells us how to start with npm init Stryker. And then we will look at mutators. So you will learn what are mutators, what mutations are provided, and what is mutation testing in general. So let's get into it. To start using Stryker, we can run npm init Stryker. I will do that here in the console. And then we will be asked a few questions. First of all, which framework do we intend to use it with? And I don't have any front-end framework here in my application. It's just a bare-bone Node.js app. So I will select none. And then I will be asked which test runner I'm using. And I find it very, very cool and impressive that vtest is working with Stryker and that Stryker has support for many, many more testing frameworks such as Jest, Mocha, Karma, so all the popular ones you will find here. And I will use vtest because I'm quite happy with it. Then it wants me to provide a build script if I have any in my scripts here, but my project works without any previous complicated build step. Of course, I'm using TypeScript, yeah, otherwise we wouldn't be here. But I have seen that Stryker has very good TypeScript support, so we don't need to give it like a pre-build. So let me just leave it with none. And then we'll check which reporters we want to use. These is then these are defining the output of Stryker. I will select the three default ones. Then package manager is also important for Stryker in order to add itself as a dependency. So I'm just using npm and I want my config file in a JSON format. Now Stryker will be added. You see here npm install. Yeah, that's why it was very important to choose also the package manager because it will update the package log file here in my case as I'm using npm. And then I can also see that in the package JSON I will find now the Stryker Mutator vtest runner. And there is a Stryker config JSON, which looks quite simple. And there will be also later on a report directory here. In the config, let's just skim it. We see that it follows a schema, JSON schema for Stryker, which then defines here the package manager that we selected, the reporting formats, and the test runner. So far, so good. Now we just need to know how to run it. Yeah, let me clean the console. It will be executed using the Stryker run command. I've set it up already in my package JSON. I have a testing goal here that I called test mutants, and it executes Stryker run. Yeah, so this is what we want to use. So I will just run the script here, test mutants, and then we'll see our first output, and then we'll go through it together. So first of all, let me quickly explain what are actually code mutations. Yeah, we haven't checked this yet. To clarify that, code mutations are actually like mutations of our source code. And this is what Stryker is doing. Yeah, it takes our original code, changes it in memory, and then runs our tests against the changed version of our file. And this way, it wants to verify the quality of our test code. Let's take an example. Like here, I have my source say hello TS file. Yeah, and let's look into it. Source say hello, and it just returns hello. Yeah, simple like that. And Stryker does now the following. It changes hello to an empty string. And then it wants to check if this is caught by my testing code. And we can see then if it is caught or not by looking here at the result set. And we can see, for example, that Stryker generated 2 mutants and 1 mutant survived and 1 mutant got killed. So what's up with that? Like, first of all, the mutant is what we can see here, the empty string. Yeah, that's a mutation, a mutant. And would look like this. Yeah, and this mutant probably wasn't caught by my testing code. So let's look at the testing code here for say hello. And there we can see that I run the say hello function and I check its return value to be defined. And with this, I will see, okay, there is a text coming back, but I wouldn't see which text, right? And since it's an empty string and still a valid text, my testing code would say, yeah, it's defined, although it's a different text. And that's not good, yeah? And this is what we can see a little more in detail when looking at the reports. So there's a reports directory. Let me just open here the mutation report. And from here we can see the live preview. And from there we can click say hello. And then we can see which mutants survived and which got killed. Killed means caught by the testing code. So when I say, okay, only show me the mutant that survived, then I can click here the red dot and I will see the diff. And the diff here is the thing that Stryker did. It changed hello to an empty string. Yeah, it recognized the string literal because it builds an abstract syntax tree of our code. Then determines, hey, there's a string. Okay, cool. So I can change the string. And then it fiddles around with the string. Yeah, it makes it an empty string and runs then the tests again and sees that the test doesn't raise an error. And that means that the mutant survived. We can also see the killed ones. Then we see the green dots here that we can click. And then we see the diff. So we can see what Stryker did. It changed, for example, the block statement here to an empty block. And this was then caught by our test code because the test code checks if something is defined. And when the block is empty, it's undefined. Yeah, so this will be caught by the test. So yeah, 1 mutant down, but 1 survived. Fixing our test code is quite easy. We can check for the exact string. Yeah, instead of checking for to be defined, which would just check against undefined, we can check that the text is actually hello. And if we then run the script again, then our page will be updated. Yeah, it takes a while, and we'll see then that all mutants got killed. 2 out of 2. Yeah, we now caught the empty block here, and we also caught the empty string. The big question is probably now, how can Stryker modify these things? Well, we talked about it by saying that an abstract syntax tree is being generated, and from there it can find out what are the constructs here of the code. But what can it actually change, or what are the limitations of the framework? And for this, let's look at my slides again, because there was a link here to the support in Mutators. And if we copy that and go there, then we will see what Stryker can do for us in TypeScript, JavaScript. And we've seen, for example, the string literal mutators. Yeah, if we check here for string literal, then we'll see that there are different mutants. So whenever Stryker finds a string literal here, this one, then it can mutate them to the following things here, either to like empty strings, as we've seen, or it then changes empty strings to filled strings. Yeah, it will then write Stryker was here if we would have an empty string. And it has also other mutants, for example, that can mimic some interpolated string. So if it finds a string interpolation, it will replace it with these variants. Okay, now we've learned quite a lot. Yeah, we know now what mutants are, we know how they are being created and what is possible by the framework. We've also learned how killed are being counted and how survived are being counted. But there's something more, and this is what I want to look at with you now, which is the timeout here. Yeah, we have a timeout column, and we can see that in the print array file, there are some timeouts. So let's look at this. First of all, I will close here all the other code files. And then I want to see here what's going on with the timeout. We have it in print array. And there we can see the timeout with the clock. And if I click here, then I can see that Stryker recognized the block statement. And it replaced this block statement here with an empty block. So what is happening then there? What is happening is, let me open this again. When this becomes an empty block, the index is not properly updated anymore, which means that index will be always below the array length because it's never updated and it starts at 0. So when the array is non-zero, yeah, and when there are some items in the array, then it will always be smaller, the index, and then we will have a continuous or like an infinite loop. Yeah, this is of course a made up example. Like this function here, print array, does nothing more than just receiving an amount of numbers and then logs these numbers to the console and returns the last item from the array. Yeah, just because. But imagine you have some more complex business logic where you use loops. Then the loops could run forever and cause your application to halt. Yeah, because maybe you then have a parameter that you haven't tested against with, and then it causes your loop to never exit. Yeah, so this could be also then identified by Stryker and could give you some ideas on how to improve it. For the sake of the demo, I want to show you how we can get rid of the timeout in Stryker. The most simple way would be using a Stryker disable comment, yeah, because you can always say, hey, this mutation I don't want to have in my code. And in this case, we could write Stryker disable, and then we only want to disable mutations for the next line. And then we can define which mutations we want to disable, yeah, because depending on what Stryker finds in your code, like block statements, equalities, conditions, it can modify many things. We can say, okay, please avoid all modifications. Then we could run the command. Let me just check. There was npx npm run test mutants in my case. And this will then run it again and disable the mutation. We are now down to only one timeout. We had two before. So let's look back at the HTML report with the viewer here. We can see now in the print array, was it right, that there's still a mutation that causes a timeout, which is now the update operator mutation. Yeah, like remember, we could see on a website what changes Stryker can make, and it can apparently also make changes on updates like the increments. So here it modifies it to a decrement. Then also the index will always be lower than the array length. So Stryker then runs it 400 times, and or here in that case 401 time, which is above the limit, and then says, okay, 401 times it didn't finish, so I will kill the test, so that we then run in a timeout. So even this Stryker disable next line all didn't help us, yeah, because it only disabled for the next line for this layer the mutation, but then the mutation is being on for this one here, which will then still reflect in a timeout. I can, instead of disabling all mutations, only disable a specific one, but I forgot actually which mutation this one was. You can always read it up when you click on them, because then you see how they are called. So let me just remove this comment for a moment, rerun the command here, so that this gets updated. because then I will see what was the name of it. This here was block statement. Okay, I could then say disable next line and write block statement here to only disable block statement modifications. And if rerunning the script here, then we'll also see that yeah, this mutation here won't happen anymore, and we are left with this one. Of course, I can also disable this one now by saying, where was it here, index plus plus, please don't do update operator as well. Yeah, next line, this one. And then rerunning it will not cause any more timeouts. But that's actually not the idea of it, yeah, because it should highlight us some things. And if we are starting to disabling things, then this is a good reminder of, yeah, can we or can't we do it a bit better? And of course, we can do it a bit better. And in this case, we don't even need to modify our test code because we can actually improve the source code. Let me show you how to do that. We have the source code here. I will make it a little better to see. I will remove the comments and I will also open the test code. The test code is, yeah, just running print array and then checking that the last item is really the last item, the 4 here in that case. I can run the tests from here, just clicking on the sidebar. Tests are green. I see the console logs. They're all fine. So the test case is good. Let me change the code here on the left side a bit, because instead of doing a while and keeping track of an index, I could just use a for. Yeah, and I could say for const value of array. Yeah, and with that for statement, I should be already good, because then I have the value of the array at hand. I can log that to the console so that my business logic is still the same. And I then don't need the index any longer, because instead of using the incremented index, I can just say array length -1 to get the last item of the array. So when I do this and I rerun my test here, then the test is green. I get to see still 1, 2, 3, 4. Yeah, 1, 2, 3, 4. So that's all good, nicely behaving. Last thing we need to check is simply then our Stryker test result. And if this is green without timeouts, then I'm very, very happy. Yes, so we have no more timeouts, but we still have one mutant that survived. Oh, ho. Where is that? Where is that mutant? It's here in the for of. Okay. Which one survived? Block statement. For const value of, when it's turned into an empty block, then it's not caught that the log is not being run anymore. Okay, so the problem now is that Stryker changed our business logic, but all tests were still green, right? Like I executed the test just before and they were green. And even if Stryker changes now our code to just an empty block, the tests are green. No tests is flagging that Stryker did a modification. Yeah, and that's not good. So we need now to extend our test a bit and improve the quality of our test code. Nice. What can we do? Well, we want to detect that console log is still being executed. Yeah, we want to detect that when it's not executed, that it's an error, because our business logic is, hey, it should log something. Yeah, and we can do that by using a mock. Yeah, we can say, okay, we want to have a mock on console log. So I will use a console mock as a name. Yeah, and I will spy then on the console and its log functionality. And then when I execute my function, I will simply check that my expect mock was called, and it should be called 1, 2, 3, 4 times, because I'm logging 4 items. So I will use that beautiful name of to have been called times 4. Yeah, that should do the trick. Let me execute the test here. That's okay, that's fine. Yeah, here the tests are all green. Then let's see what Stryker has to say. Simply rerun it. And ta-da, 100, yeah, score of 100. Killed all mutants, none survived, no more timeouts, all great. We've just seen how Stryker can help us to improve our initial code, but also our testing code, yeah, and that's actually the first thing that it wants to achieve, that we write better tests, yeah, so it's there to help us improve our tests per se, but in this case it also helped us to refine our business logic to not run into infinite loops. By the way, when Stryker creates these mutants, yeah, that is also called sometimes defect seeding, because it creates a lot of defects in the code. You can see the defect seeding when running the command here to Stryker run, because you will see then that here, yeah, there was a small progress bar, this one here, right, where it creates then all these mutants, seeds the defects, and then runs your tests against those mutants, mutated code. The thing is that this can take some time, yeah, like it can take longer than just unit testing, because it needs to create many variants of your code. You will also see that here in the logs. And the bigger your code base is, the more mutations are there, of course, and then the longer it takes to run all of this. So the recommendation is to run it on new pull requests. Yeah, whenever you write new code and you write new testing code, then it's a good idea to run mutation testing as well, to have great testing code from the beginning. But you can also make it part of a separate pipeline that you want to execute once in a while. Yeah, maybe with GitHub workflows, where you then execute it manually to not have the progressing time and the waiting time for the result in every CI run. Okay, another feature I want to show you is how Stryker can also identify unnecessary tests. And that's something that we can also see from here, from the table. We see, for example, that the add.ts file here has a score of 0, and that there is no coverage, yeah, like nothing is being covered. And that's maybe surprising, because there is an add test.ts file, but in here we see now that there is a skip. Oha, we forgot to enable these tests, yeah, so let's just do that. And if we do this and then rerun it, the results should look different. And ta-da, yeah, now we are at 100. Super cool, yeah, now everything is great, like all files have killed every or all possible mutants. We get a score for that, and we can also see that then here in our newly created report. From here we can also check the test column, and that's something I want to also encourage you to do, because there is some information here that is very beneficial as well, which I will show you now. Let's assume your code base grew over time. Yeah, maybe 20 people are working on it, it's 5 years old, and a lot of tests have been written as well. And it could maybe be the case then that colleague B wrote some code, wrote a test, and colleague C also wrote code in the test, which actually also tests inherently the code of colleague B. Yeah, then you may not need all test files and all the test code, because maybe some tests are overlapping. And that's something that you can also discover using Stryker. And this is something that I will show you, because let's say that here in say hello, I will have another test that tests the very same thing. Yeah, let me just change it. It tests the same. And then I may have a test which doesn't hit anything at all. Yeah, just empty. It tests nothing. Then these maybe 2 tests, yeah, would not be necessary anymore, and I would like to figure that out automatically in a report. When I run Stryker, then I will see that in the testing column. So Here everything looks green and everything looks okay, right? But when I go then in the report, in the tests, I will see here the not covering state. So when I check then the say hello tests TS, I will see that there's one test that actually killed a mutant. Yeah, that was the returns hello test. But then the one that covers stuff, which is already covered, gets an umbrella. Yeah, that's the thing that tests the same. Yeah, this one is covering things, but not killing any mutant because all mutants have been killed already by the first test. And then there is test code that doesn't cover anything at all. Yeah, here the test nothing one got identified as such. So that's a test case that we may want to remove. As a final feature, I want to show you that you can also change that website into dark mode, which is quite nice. And yeah, that's it for this session. Like I think like the features are very, very clear. Like you can identify not so well written test code, and you can add an extra layer of protection for your functionality. Because you may think, well, I actually have unit tests, and when I have, let's say, 100% code coverage, what can happen to me, right? And that's actually what I have here in this small example as well. Let me just show you. I will just run npm test, and you will see that I have 100% code coverage. Yeah, like all files have been tested, everything is 100%, tests pass, super nice, yeah? But remember how we started. We started with a test case that just tested if something is to be defined. Yeah, let's say here, hello is to be defined. If I only have this, I will reach 100% code coverage as well, because code coverage just means that every line of code has been traversed by a test. And that will be achieved with that because say hello is being executed, so every line of it will be tested. But the test is not meaningful. And that will be very obvious to see if, for example, say hello doesn't say hello anymore, but let's say goodbye. If this is the case, and if I run npm test again, then I will still reach 100% code coverage. Everything is tested, everything is green, everything looks super good, but it's actually not doing what I'm expecting it to do. And that's something that you will find out with Stryker. Yeah? When I run now npm run test mutants again, I will get to see not 100 because I will have a mutation in there which isn't killed. And that's the purpose and the big benefit that Stryker gives you. It's this extra layer of confidence in your test and then ultimately in your code.